Hi, hello everyone. Today we are going to discuss a very famous interview problem, that is best time to buy and sell the stock. I myself has experienced this question multiple times during my interviews, and I'm going to discuss this problem statement, intuition behind the problem statement, how we can solve this problem using brute force approach, how we can optimize that brute force approach, to try to understand uh, how we can solve problems which are based on the same pattern. We are not just going to understand the single problem on lead code. We'll try to understand the intuition. We'll try to understand the approach behind it. We'll try to understand how we can solve problems which can be derived from this problem. Okay, so let's start with the problem statement itself. You are given an array prices where every index will represent the price of stock on particular day. So your task is to choose a single day to buy a stock and choose another day in future to sell that stocks. You'll have to choose these two days in such a way that the profit you will get should be maximized. Okay, let's try to see the problem statement using example. So if you see the first example, it gives on first day price of stock is rupees 7. On second day it goes to 1, then it again rise up to 5, then it goes to 3, then 6 and 4, right? So to maximize the profit, what we can do, we can buy on second day when the price of stock is rupees 1 only, and then we can sell it on third day when the price of not third day, basically on second last day when the price of stock is 6 rupees, right? So we will get the profit of rupees 6 minus 1 5. So this is the general problem statement. Let's try to understand the intuition behind the problem statement. Let me take the example here. What it says, 715364. So it says we are given the price stock as 7155. Submit. It's working. 715. What are the other? 715364. Okay, 715364. So the intuition behind the problem statement is you will try to find out the difference between minimum and maximum. Try to understand this problem in terms of minima and maxima, not yeah, minima and maxima, not exactly minima and maxima. Yeah, it would be global minima and maxima. I was thinking in terms of local minima and maxima, but I think global minima and maximum would work. But there is a condition: your minima should occur before the maxima, right? What does it mean? Let me try to represent this in on a graph, right? One, let me write a number line: 1, 2, 3, 4, 5, 6, 7, 8 and so on. We just need till 8. So here as well, y axis as well. These are the days: 1, 4, 5, 6, 7. Okay. On first day price of stock is 7, right? On second day it's 1. On third day it's 5. On fourth day is 3, right? On fifth day the price of stock is 6, right? On fifth day it's 6, so it would go here, somewhere here. On sixth day it would be 4, so it will go to somewhere here, right? So when I try to connect all the dots, what I will see, on first day it goes to 7, on second day it goes down to 1, on third day it goes up to 5 again, right? On fourth day it comes down to 3, on fifth day it goes to 6, right? On sixth day it again goes to 4. So what our task is to find a minima which is followed by a maxima, right? Our task is to find a minima which is followed by a maxima. I have this minima, right? I have this minima, and then maxima. Let me pull it down, just holding the point so as to make it more readable. No, here we don't have any point. So if you see, a task is just to find one minima. This is first minima, which is followed by a maxima, right? Which is followed by a maxima. These 2 points. So what we can do, first, now we get the intuition behind the problem statement. Now we try to solve this. How we can solve this? What I can do, I can take every point. What I can do, I can take every point and find a maxima from that point, right? What I can do, starting from 7, I can see if any maxima after this. No, I cannot find any maxima after this. So after 1, what is the maxima? After 1, I have maxima 5 and 3 and 6. I have 3 maximas, right? I have this 5, I have this 3, I have this 6. I have 3. These are not maxima, these are basically maximum values, but maximum would be the 6 only, right? The maximum of all the maximum of our current value, right? So we have this point, this point. What we will choose? We will choose the maximum of all 3, right? So for 1, for 7 we have 0, for 1 we have 5, 6 and 3. Let me write in series only. 5, 3 and 6. For 5 I have only 6. For 3 I have 6, right? For 6 I have nothing. For 0 I have nothing, right? So what I can do, I can easily code this in our code, right? I can take 2 loops and then I can go ahead with those 2 loops by taking each element one by one and then finding every element after that which is greater than my current element, taking the maximum of all of them, right? This is straightforward using 2 loops, but that would be difficult for us to be, because our interviewer is not going to be expecting this solution from us. He is expecting something better than that. It's not, because the time complexity of our 2 loops would be big O n square, right? But we can still solve this problem in big O n as well. Now let's try to visualize. Let's try to visualize what I can do. I can just traverse this loop in one way, in just one traverse. How I can solve this? Let me take you to that approach as well. What I can do, I can start with my current element, right, and assign this to the minimum value, right? If I get next element as minimum to the current minimum, then I can update my minimum, because what I need to do, I have to find the minimum and the maximum after that minimum, right? So my previous minimum doesn't make sense to me, so just I have to update the minimum. So if I first assign my minimum to 7, if I go like this, minimum is equals to first element, which is 7, right? Then I go to second element, which is 3, which is 2, which is smaller than my 7. Then I will update my minimum to 3, right? Then let's move forward and see if my next element is smaller than my minimum. I would say no, it is not smaller than my minimum, so I can make some profit. So I can say my possible profit is next element is 5, 5 minus 3, which is 2, right? This is my possible profit. Next element comes to be 3. Next element comes to be 3. I can again find the possible profit, right? Uh, Possible profit, this is possible profit, and I will maintain a global profit as well. Current global profit would be 2. So when we traverse 3 and we see again, wait a minute, I updated here on second element, I have updated it to 1, because not 3, it should be 1, because second element is 1. 5 minus 1 would be 4. So my possible profit is 4, my global profit would also be 4, because initially it is 0. When I come to the fourth element, it's 3, right? When it come to the fourth element, which is 3, so my possible profit would be 5 minus 3, which is 2. But should I update my global profit? No, because I have already seen my global profit is already greater than 2. So I can say I can make a profit of rupees 4. I can also make a profit of rupees 3, but considering the problem statement, I should be making the maximum profit. So for that, what I am doing, I am not updating the global profit, but I am calculating the possible profit. That comes to the let us try to compute for the next element, which is 6. Now possible profit is we are not updating minimum. We will update minimum when my current element is less than my minimum. Okay, we will not update minimum, we'll just update the possible profit. Possible profit is 6 minus 1, which is 5. My global profit is 4. I know I want to make the maximum of all the profits, so I will update my global profit as well. So global profit would also be 5, right? Next I come to 4. So here I can also make some profit. Let's check the possible profit, which is 4 minus 1, which is 3. But it is not greater than my global profit. So I can say my global profit would be 5 and I will return my global profit. I think I made a point. I hope did I miss something? I don't think so. So in if we want to explain this problem statement in a single line, so we would say that we are supposed to find the running difference of minimum and maximum. Okay, we will find the running minimum and maximum, find the difference between them, right? Because what this is what we are doing, we are just moving from left to right. If we are getting minimum, we'll just minimizing it, and if we are getting maximum, we'll finding the difference and updating the profit. This is in general statement or in just single line. Let's try to quickly implement this on Leetcode. Okay, I'm doing this in Java. You can do this in any language. I'm just for clarity of reading. Let me quickly write it. So int global profit be 0, right? Sorry for typos. Profit equals to 0, right? And int my minimum would be s of, right? Not considering the edge case. Edge cases where length of s equals to, okay, for int I equals to 0, I is less than s dot length I plus plus, not 0 because we have already traversed 0 and we should go from 1, right? Starting from second element going until the end, and we'll check if my s of I is less than minimum, then I will what I will do, I'll just update my minimum, right? What I will do, I will just update my minimum is equals to s of I, right? Else what I will do, else I will say, I will check if, or let's say global profit is equals to global, just doing the shorthand, profit equals to math dot maximum of global profit, right? uh, Profit and s of I minus 1, not minus 1, minus minimum, right? Whatever value we are having, it would be either greater than or equals to my minimum. So I will update the global profit if that difference is greater than my current global profit, right? Let me check if goes to, yeah, it's at least 1, so we don't need that check of null array or empty size array, and should return global profit, global profit, right? Try to run this. Hope I'm not making text mistake. uh, okay, I have just written the m. Okay, it's passing both the test cases. Call it, oh, for case 1 selected 5 getting 1. We try to submit this. Okay, so it's getting submitted as well. You can have a look on the code. I can take you through the code one more time. What we are doing, we are initializing global profit or our answer to 0, and we are initializing our minima to the first element. Starting from the second element, we are checking if the element is smaller than our current minimum, we are updating our minimum. If it is not, it is greater than our minimum, it is greater than or equals to our minimum, we are just updating our answer or global profit, whichever variable name you are choosing, by taking the maximum of global profit and my current element minus minimum. Okay, okay, so I'm wrapping this video here. If you have any doubt, you can write that out in the comments. I'll try to answer. Until then, goodbye. Meet you in the next video.